right. And that's an important thing for us to know because the formulas we can use to find these next things, we actually use that kind of language and variable. My bruise, I know. It's not going anywhere. I can't help it.
You get beat.
It's making me sad.
I noticed it now.
It's been there for 2 weeks.
No, I noticed it last week, but like I don't have.
Yeah.
And I didn't go when I hit you again.
Yeah.
So I think what if it had to be?
You remember when I had that dental surgery? That bruise has been there since then. Yep, you are sitting over there. Oh. Here, you need this paper. You can grab it. It's right there. I can't reach it.
Ice on it, you put ice on it.
I put ice on it.
We'll put ice on it every day.
The bruise is already there. The ice doesn't make the bruise go away faster.
Aloe vera.
I've been trying, y'all.
You should try it. Ice makes bruises go away because it does
It reduces inflammation, but the problem is, I think this is like, I don't know. It will not go away. If it's gonna be there forever, I'm gonna be so sad. Like, so sad. Hey, I've been color correcting it so it wasn't as noticeable, but I'm going back to the dentist today to let them look where they did the surgery thing, and I really want them to feel bad. So I'm debating taking a makeup remover wipe and wiping it off before I go in there and be like, look what you did to me. Do you see this?
It's worse than it is.
It's worse under there. That's got makeup on it and color corrector.
Right now.
Not a lot.
Like.
Like a little bit.
Show us.
Y'all are annoying. All right. So whenever we have to look at the formulas, okay? We have recursive formula, okay? A recursive formula just gives us the next term. So when we have a recursive formula for arithmetic sequences, we can use it to find any value, okay? And what we do is we take our difference and then we add it to whatever our next term is. So we take the previous term.
Does D stand for difference?
It does. Okay, and we're going to add that to the n minus 1 term. So you know what that means?
Nope.
We're just going to take, if I want to find A6, right? I'm going to do 3 plus, what is 6 minus 1? 5. So I'm going to do, to get A to the 6, or A6, we're going to equal that to the difference plus the 5th term. So 3 plus 52, what does that give us?
55.
All right. It's just the equation for writing the next term. That's all that is. Okay. Then the explicit form, yes.
Oh, can I turn this into my teacher instruction?
Yeah, go ahead. Grab the pencil pass. All right. So for the explicit formula, okay, that can be used to find any term. So even the next one, it can be used to find absolutely any of them. Okay. And the formula for that is we take A1, which is our initial term, and we're going to add that to D times n minus 1.
What would be an example of this?
3.
3. Okay, all right.
You just take whatever the difference is. Okay. These formulas are formulas. Okay. They are formulas that you were just going to plug into. This isn't something I'm expecting you to intuitively know. Okay. It's just what's happening in the sequence to find any term. Basically, that right there creates a linear function. Okay. That's why we're not going to be focusing on those as much because we've already talked about linear functions. But when we start looking over here at geometric, it's going to be something that's really, really, really similar to what we're doing now. So for geometric, okay, it's a sequence where the ratio between the consecutive terms is constant. So do y'all remember how at the beginning of exponential, how we could find the constant ratio by looking and see what we multiply to get to the next one? That's all this is. It's the same thing. So we have to multiply to get to the next term. and it has a common ratio. In this sequence, what do I need to multiply -4 by to go to 12? -3. What do I need to multiply 12 by to go to -36? Same thing. So what would your common ratio be for this problem? -3. Okay. And so again, we have our first term, we have our second term, our third term, fourth term, fifth term, and then we can go all the way to n. And n is just any.
Any number.
All right, so for the recursive formula for this one, okay? So again, we're looking at how to get the next term. So let's do this. If I ask you to find the next term after -324, how would you do that?
Multiply it.
Multiply it by -3. So we're going to take our ratio and we're going to multiply it by the previous term. That's all we got to do.
Why are you subtracting 1?
So saying n minus 1, we are not subtracting 1 from the number, okay? If we're trying to find, let's do that. If I'm trying to find the 6th term, I have to look at the 5th term. 6 minus 1 is 5. This is just a way for us to write that for any number, because that can be 70, and that would just be 69, or so on. Yes?
So the answer would be a equals -3, 5, 8, and -1.
Not gonna be able to test.
All right, so for explicit formula, okay, this is so we can use it to find anything. So we're going to say an is equal to, we're going to use our initial value, which is a1, and we're going to multiply that by our ratio to the n minus 1 power. What kind of function is that right there? Exponential, right? Even down to the fact that this is still our starting value. That's still our initial value. Okay, and that's our ratio. It's the same thing. So that is why it is in this unit, is because it's literally just an exponential function. We are going to focus more on geometric than we are on arithmetic. Okay? Pretty much the only thing we're going to look at for arithmetic is just being able to identify it. So right here, all of the variables that I used up there, it is explained right there. Now, we're going to look at these and we're going to determine whether or not they're arithmetic, geometric, or neither. Okay? So I want us to look at number 1. So number 1. We're going to look at the difference and we're going to look at the ratio, right? So to figure out if it's arithmetic, okay, we'll say 16 minus 4. What is that?
20.
And then we're going to do the next time. So we'll do 36 minus 16. What's that? 10. No, it's 20. Are those two things equal? Since those two differences are not equal, it is not arithmetic.
So we just pick a random one.
Is
That's
it
why
not
we did 36.
geometric either? Because once you get to 64 and you try to do times 4.
Let's look.
Why would we do 36?
Okay, so for geometric, I would do 16 divided by 4. What is 16 divided by 4?
4.
Can I do 36 divided by 16? What does that give us?
4.
Doesn't give us 4.
It gives us some.
What does it give us?
I don't know.
Are those two things equal?
No.
So is it geometric? So it is neither.
Wait, why we pick 36?
You literally just pick two terms
Okay.
and check divide it and see if they're the same. It doesn't, I could have done these two. It really doesn't matter.
That looks so much more complicated.
Like, this is gonna be on the test.
So,
What would you do?
Well, I mean, we're gonna have to calculate the formula, but we're gonna do that in a second. Yes, ma'am.
so like, the way you did it, okay, that's like a good way too. But like, if I was trying to see if it was all like, if I could multiply by like, could I do that?
You can do that to check for geometric, yeah. So I just did this. This is a way that will always work to tell you if it's geometric or arithmetic, okay? Most of the time when you are looking at it, you will be able to tell, okay? This one, geometric, arithmetic, or neither? Geometric. What is our common ratio? What can I do each time? Multiply by 5. So that makes it geometric.
If you get added, it's arithmetic.
Yep. So run times by 5 each time. All right, for number 3.
It's plus something.
It's plus something. What is it plus?
8.
Plus 8 each time. So what does that make this one?
Arithmetic.
Why? Because it's adding?
Yep.
Wait,
All right. The ones at the bottom, they're a little bit more tricky. All right, so let's check number 4 using our calculators. Let's just check it for both of them. See if it's either. We're going to start with arithmetic. What is 13 divided by 3 minus 4?
Negative 4.
Hmm?
That's what I put.
Why we minus by 4? 3.
Because it's the term in front. It should
Okay.
just be
whatever.
1/3, yeah. All right. Then let's check the next two. 14 over 3 minus 13 over 3. What does that equal? What?
Whatever 3.
Do those two things equal?
Yeah.
Okay. And so that means that's a difference. So is that arithmetic or geometric?
Arithmetic.
Arithmetic. Do what?
How are they different?
What you mean?
Is that like, oh, the difference between
The,
each one?
it's plus 1/3. Yep. To go from one to the next, it is plus 1/3. That's what makes it arithmetic.
We could have done 5 and 6 times.
You could have done 5 and 16 over 3. Yeah. It does not matter. All right. So for number 5, what is -1 minus -3?
Plus 2.
2. What is -1/3 minus -1? Is it 2? No. Okay, so it's not arithmetic. Can that be geometric? Well, so -1 divided by -3 is what?
I don't
1/3. It's literally just 1/3. You want to write it this way? -1 over -3, 1/3. What is -1/3 divided by -1? What is anything divided by 1? Itself, right? And a negative make a? So it's geometric.
What?
Because to go from 3 to 1, you multiply it by 1/3.
Okay.
All right. For 6. How can I take it from -2 to 1/2? I can divide it by what?
By negative.
Dividing it by -2 wouldn't work. Not 1/2. Not -1. You are dividing it by something to get there. Be negative
Would it be -1? Would it be 1/2 divided by negative?
-4.
-4. Okay, and so dividing by -4 is the same thing as saying multiplying by -1/4.
How we divide by
-2 over -4.
It's 1/2. Yeah.
Why couldn't we divide it?
Because when we're doing this, the only way to get to the next one is we multiply. So
Or add?
so you're gonna multiply for geometric, and then you can add or subtract for arithmetic. Yeah. So we're gonna geometric. Okay. So That's all we have to do is just identify between the two. Now I want us to go ahead and flip to the back. So this sequence right here, I misspelled that. That is supposed to be IC right there. I apologize on that. I just got ahead of myself and I was getting real fast. So is this sequence arithmetic or geometric? Geometric. How do you know?
Yeah.
Yep. What both times it needs to be multiplied by? Negative 2 or positive 2? Positive 2. So we're going to multiply each of them by 2. Okay. So that means it is geometric. All right. So we're going to use a geometric example and we're going to write out what our two formulas will be. So we're going to start with the recursive formula. Okay, recursive formula is just a fancy way of us getting to the next term. So the only piece of information in here that I need to write in here is my common ratio. What is my common ratio?
I mean,
2. That's all I need to put.
Are we going by the thing we did?
We're going by this formula right here. Now, if I want to, I can label everything. So A1, A2, A3,
you gotta distribute the 2.
A4. You got to multiply 2 each time, and it's going to go all the way to A to the N.
So we're gonna get 2AN.
So for explicit formula, you don't have to distribute anything. You're good. You just leave it just like that.
How does that tie with the next one?
So I cannot get you to the next one until we pick a number to put in there.
Okay.
Yeah. The next one gives us any number. Okay. So in this one, I need our initial term and our constant ratio. What's our initial term?
A1.
Which is what? And we're going to multiply that by what's our ratio?
Our ratio is 2.
The constant ratio is 2. And so we'll do time to the power of n minus 1. That's all we have to do to set up the formulas. Okay. So I want us to look at 8 and 9. We're going to do those two together. Okay. These are geometric. Okay. This is where it will come together and you will figure out what you got to do. Okay. To go from 1/3 to 1/9, what would I need to multiply both of these by? 1/3. Okay. So our constant or our common ratio is what? 1/3. So now we're going to just take that and write our recursive formula. So we're going to do a to the n is equal to 1/3 times an minus 1. We only plug in for the r because the other stuff is dependent on what the question asks us to find. Yes. Now we're going to do explicit.
AN equals 1/3 1/3 to n minus.
Perfect. Because for this one, I had to use my A1 term. And then the 10th term. We're just going to do A to the 10th. So we're going to do 1/3 times 1/3 to the 10 minus 1. And then you just put that in your calculator. And it will be very, very small. So your calculator might tell you something weird. You will have to have them. I'm going to allow y'all to have a note card. But you are responsible for making your note card. It's Friday. What does it tell you on your calculator? Even if it's a little weird.
Wait, how do you break that on the calculator?
You just type it in just like that.
I got
So
one.
fraction key, parentheses, fraction key, parentheses.
I got
Exponent 10 minus 1.
How do you add the 8?
1.69350781 e to the negative 5.
Okay, so give me 1 point what?
1.69.
Then it was e to the
Negative 5.
perfect. That right there just tells me my decimal place moves 5 times to the left. So that is the same thing as saying 0.0000169.
We doing that to finish.
Yeah, that's all that means. All right, and how tiny of a number is that?
Pretty small.
Really tiny, right? Because if I keep going times 1/3, times 1/3, times 1/3, times 1/3, it's going to keep getting smaller and smaller and smaller and smaller and smaller. All right. Now we're going to do the same thing for number 9. Okay, for this one, what is our common ratio?
Negative. Or 1/2.
It's not going minus 30 because it's changing each time, right? It's geometric, I'll tell you that. Times 1/2. To go from 60 to 30 is times 1/2. To go from 30 to 15 is times 1/2. So our ratio is just 1/2. Now, just because I want to go ahead and label it, what's my A1?
60.
Perfect. So to go recursive, we do AN is equal to,
1/2 times 8 and minus 1.
yeah, it's just N minus 1 right there.
So why was the last one common ratio? Now it's ratio.
Hmm?
It's the same thing. Like,
Yeah. I just didn't want to write common out. Okay. Before we do that one, we got to do our A1 terms. We got to do A1 times our 1/2 to the N minus 1. Okay, now to the 30th term.
A30.
Yeah, A30 is equal to 60 times 1/2 to the 30 minus 1. Use a calculator to tell me that.
why'd you put 30?
Because we are doing the 30th term.
Oh.
All N is which term is it? So if we're not given a specific term to find, we just leave it as N. But if it tells us to find a specific term, that's when we plug it in.
What's it do?
N just means any number.
I wrote it on my paper.
I got 1.11 e to the negative 7.
1.11 e to the negative 7.
Or if you round 1.12
Okay, let's do 1.12. So I just moved that to the left 7 decimal places, so it'd be 0.1 or 0.00000000112.
It literally says it on.
So the decimal place is to the left, 7. Oh, 1.1.
So you're gonna put 1 less 0 in front of it than 7. Or you can just literally show yourself 1.12 and go 1, 2, 3, 4, 5, 6, 7. Then everywhere there's a little thing, you put a 0.
So we have to write the decimal point.
Please. I just wanted to make sure you know what it means. Because this is meaningless if you don't know that it's that. All right. So I want you all to do number 7 on your own for me real quick. Find your ratio and then do each of the pieces. I can tell you're tan. Did y'all do it for?
discount too, because it was like
For which one?
13 of us doing it, so it was only $30.
The
That's not
first, I
bad.
think,
She does
first or
really
12th.
Did y'all have to get one?
I'll do it right now.
I mean, the black girls don't have to, obviously, but,
All. Did y'all get one though?
there's a few girls that did.
I never
That's
really
like why, you're gonna be like.
I never did with dance because I just let myself glow.
9,797,650.
All right. Let's go through the whole thing. What's our common ratio?
5, yeah.
Okay, to get my recursive formula, what am I going to do?
A equals 5 with an minus.
What's our explicit?
A equals 2 times 5
Oh,
to
2.
n
Why is it
minus
2?
20.
Because we use our A1 term.
Okay.
Okay, and then it's to the n minus 1. And then so when we do this for 12, we'll do 2 times 5
We just have to run
to the 12 minus 1. All right, and then what power, or what is that answer going to be?
I got 96,250.
That was too fast. What? 97 million. 250. That's a big number, right?
Pretty massive.
Yep.
Massive. What else is massive? What else is massive? What else is massive?
More.
Nothing that y'all got.
Okay.
That's not funny. You should have named things like that.
I'm not laughing. I am not laughing. Ooh.
She's thinking about her dog.
You think about your dog?
Why do you keep saying at the beginning of the year, she said you talk about her dog so much.
Anyways. Whew. All right, for number 10. Okay, it gives us the explicit formula. Okay, so we have to write the recursive. So before I do anything, I'm just going to write out what I know from this. What is my A1?
-4.
What is my ratio?
3.
Perfect. So to write the recursive, I'm just going to do AN is equal to my common ratio times AN minus 1. This part is easy. Because
Are you gonna introduce us to something else?
we're reviewing all day tomorrow.
Okay.
I won't be here Friday. Neither will Molly. This
I
Friday.
don't know.
All right, for this one. Okay. What is A1 for this one?
5.
What is our ratio?
2 over.
Okay. Then to write the recursive formula, it'll be AN equals.
Equals 5.
No, 8. No.
Yeah, AN equals. Do I use my initial or my ratio?
Wait, what are we doing?
We have to do our recursive formula. We're just following the directions. AN minus 1. There we go. Now, the last one. It gives us the recursive formula, and we have to write the explicit. Okay, so it already tells me A1. What is my ratio from that?
0.05.
So now all I have to do is write my explicit. So I do what?
Wait, our explicit
To the,
to the point.
she was answering it too. There we go. Now that is all we gotta do for that. So I want us all to go to the homework packet 6.5 and 6.6. We're gonna go over most of it.
With the 12-term stuff, I don't know whether it's recursive or explicit.
So to find anyth term, you use explicit.
Okay.
You really only use recursive if it's telling you to find the next term in the sequence.
So we can use a whole note card for this.
So tomorrow we're gonna review all day. Okay. You are going to. I'm not gonna leave. There's gonna be nothing on the board during the test. I'm doing that just because that way there's no way something gets erased, anything like that. However, you can take one note card, front and back, and put whatever you feel like you need on there.
What if my note card was just the size of your board?
Then it would not be a note card. You cannot purchase a note card that big. So you can use a 3 by 5 inch note card. I made sure to add in the units, so no one brought a 3 foot by 5 foot note card. It is a 3 by 5 inch note card. It is the small ones, yes, front and back.
I think it's pretty heavy.
All right. So on the homework. Oh, Lordy. All right. So we did the top part of this yesterday. So right here, I just want us to do this part. It just says determine if it's geometric, and if it is, find the common ratio. Is 5 geometric?
No.
Why is it yes? What's the common ratio? Times -4. Geometric.
I want to multiplied by negative, it wouldn't be.
As long as you are multiplying it by something, it can be a fraction, it can be negative, it can be positive, it can be whatever. All right, for number 6. Okay. This isn't arithmetic, right? We can clearly see that. So to check to see if it is geometric, you would do 1,276 divided by 127. What is that? I need to know the exact decimals.
10.047244.
So 10.05?
Oh, yeah.
Okay. Then to get the next one, to check the next term, I would do 12,766 divided by 1,276. What does that equal to, Ramsey? Or do you got it?
I didn't do that one.
Somebody got it?
I got 10.004.
10.004. Are those two things the same?
No. So,
No. So is it geometric?
No.
It's not arithmetic. This one is.
Nothing.
Yep. What is the only pattern this question has? It's just adding 6 each time, right? It's just putting an extra 6 on the end. That's all it's doing. There's no math about that. That's just somebody thought that was fun. All right. Cool. Now we're going to look at the next section. So this one's just us writing the recursive formula. The recursive formula is AN is equal to, we take our common ratio and multiply it by AN minus 1. So the only thing I need to find is what? Common ratio. Okay, and these are geometric, so we're good to go. What's my common ratio?
Times 30, which is 3.
Just like that. That's all we do. All right, then we're going to look at the next section. So explicit formula. Okay, that's where we do AN is equal to the initial times the ratio to the n minus 1. So I need 2 things. What 2 things do I need? All right, so for number 9, what's our initial?
Our initial is -2.
Okay, then what is our ratio? Times 2. And so we are good to do that formula. It'll do AN is equal to what?
Wait, -2 times 2. Oh, yeah.
Perfect. That's all we got to do.
I'm on 11, that's all.
All right. Now, this next section, it just says using the explicit formula, find the 8th term. Okay? So to use explicit, I need A1 and I also need my ratio, right? So what is my A1? What's my ratio? And so we're just going to do A8 is equal to -2 times -4 to the 8 minus 1. That's all we got to do. And plug that in our calculator. That one, the only difference between that one and the last one is what? I'm plugging in the number it tells me to. That's all I'm doing different. This test is formula heavy, unfortunately. So what do you think would be important to put on your note card?
All the formulas. I got 30.
And not just put the formulas. What else should you put about the formulas?
Label.
Label them. Yes, that would be excellent. All right, what's the answer to this one?
I got 32,768.
32 what?
32,768.
Perfect. Then we're going to do number 12 together too.
Okay, 81 is 2.
Wait, what was it?
32,768.
Miss Dawson.
Yes, ma'am.
You said that this is not standard for.
32,768.
Okay, for 12, what is A1?
2, 2.
2.
For this one, what is our R? -2. So
How'd you get?
that's from our question. At the top, it tells us to find the 8th term. And then it'll be to the 8 minus 1. So we just go ahead and plug in. And that is all we got to do. Okay, and you are responsible for finishing that page. Okay? Test day. Okay. When is our test? Friday. When are we reviewing?
Tomorrow.
Tomorrow. Okay.